All right, class. So today we're going to work on linear functions. We're going to work on linear functions. This is going to be page 13, and this is EOC review number 2. So we got Q4, and today's date this is going to be page 13. Sorry. And today's date is 4/28/21. And again, this is going to be on linear functions, okay? Linear functions. All right, a linear function, or we're going to say equations because not all linear equations are functions, okay? The equations that are not linear functions are going to be the x equal equations. Those are the only equations that are not functions. All right. A function by definition is where the x values do not repeat. The only linear equations that are not functions are going to be your x equals. I need to write that in. So it's super important. First of all, a linear equation are equations that graph straight lines. Linear equations are equations that graph straight lines. Okay? And this is what they basically look like. I have different kinds of linear equations. I'm going to draw my x and y axis. We'll do 4 different small graphs, okay? Let's draw 4 small graphs. So the 4 small graphs that I draw, you have a linear equation where your line may be going up, okay? And this has a positive slope to it because the line, as x increases, y increases, okay? You might have a linear equation where the line is going down. This is a negative slope where x increases because x always going to increase because you always read x from left to right. As x increases, y decreases. You might have a slope that has a flat or straight line, a horizontal line. This is no slope because it has no steepness to it. And then you have a line that is vertical, that's just straight up and down. This has undefined slope. And again, your meaning for slope is going to be the steepness of a line. Nonetheless, these are what linear equations, when you graph an equation, if it graphs a straight line, they are considered to be linear. The smaller word in linear is line. Equations that graph straight lines. Now, the only equation that is not a function is this one. This is the only equation that is not a function. Not a function. And it's not a function. Let me put a not. It's not a function because all of these x values, all of these points that are on this line have the same x coordinate. So all the x's repeat in a line that's like this. So a function is where your x values, if it's a function, your x values do not repeat. Function is when x values do not repeat. And that goes for any function, linear function, quadratic function, exponential function. The x values do not repeat. If they repeat, it's not a function. And therefore, that's why this line right here is not a function, because all of the points that are on this line have the same x coordinate. So that means this is not a function. It fails that vertical line test. Okay, so now equations, most equations are written in slope-intercept form. So we got most equations are written in slope-intercept form. And slope-intercept form is the way an equation is written. Okay, so let's look at your slope-intercept form there. Okay, a form is the way something looks. So equations that look like this are in the slope-intercept form, and they are linear. So we have, again, names for x and y. I've said this many times before. Your names for x and y. X can be called your domain values, your input values, of course, x, and your independent variable. If they ask for your independent variable, what they're asking for is the meaning of x. Okay, most of the time, x is time, years, age, days, months, most of the time. Not all the time, but most of the time. Okay, your y, other names for y, and this is in all functions, is your range values, your output. Okay, your dependent. If you are asked for your dependent variable, what they really want to know is the meaning of what y is in that particular problem, the meaning of it. And of course, you have f of x, g of x, whatever of x. This is another way, it can be n of x, t of x. This is another way to write y. Okay, and when you use f of x or g of t, that's called writing an equation in function notation. Okay, just by changing y to f of x, you're writing that equation in function notation. All right. Okay, so you got the meaning, or you have the meaning for x and y, the meaning for m and b in a linear equation. The meaning of m is your slope. That's the steepness of the line, how steep the line is. If m is a negative number, the line is going to go down. If m is a positive number, the line is going to go up. Okay. And then your b is called your y-intercept. It's where your line crosses the y-axis, or it's your starting amount. Okay. Or it's your starting amount. All right. And this is the slope-intercept form. Okay. This is the slope-intercept form. Okay, most equations are written in that slope-intercept form. So let's take a little bit of a look at your slope-intercept form. Okay, some examples of what that looks like. Equations written in slope-intercept form are going to be linear, of course. If they're not written in slope-intercept form, you can write them in slope-intercept form. It doesn't mean that the equation is not linear. It just means it's not written in slope-intercept form. Okay. What makes a linear equation is when you graph it and it forms a straight line. Not all equations obviously have to be written in slope-intercept form, but they are most of the time. Y is equal to 2x plus 7. My m, or my slope here, is the number that's attached to the x, which is 2. And my y-intercept, or my b, is 7. Okay, y is equal to negative 1/4 x. Make sure that x is not on the bottom of the fraction, but if you write it, it can be on the top of the fraction or out to the side. X, if it's linear, x cannot be a denominator. Okay, when x is a denominator, it is no longer linear. Then we got minus 6. So your m here is negative 1/4. And your B here is negative 6. All right. Any questions about how to identify? If you still have questions, please make sure that you contact me and let me know. Okay. All right. So now you need to understand how to find your slope. Okay. The formula, or rate of change. If it's a word problem, please make sure you identify the 2 points, because you have to have 2 points. You have to have an x coordinate and a y coordinate. Since there are 2 points, your first point that's given is going to be x1, y1. Your second point that's given is going to be x2, y2. So I'm going to make these up. Let's say 0 and 7, and then 8 and 2. Okay. The formula for calculating slope is y2 minus y1 over x2 minus x1. And this is the same formula you're going to use to calculate the rate of change as well, even if it's in a function table. Okay, X and Y table. And you have multiple points. You just choose two of the points, or they will specify which points they want you to use sometimes. Okay, so now we're going to take these 2 points and we're going to substitute them into the formula. You have y2, which is 2, minus, it's a part of the formula, y1 is 7. Then on the bottom, you have your x2, which is 8, minus your minus 0 there. So here on the top, this gives you a -5. And on the bottom, this gives you 8. And make sure that your fraction is reduced, or you can convert your answer to a decimal, which would be -5 divided by 8. And that gives you, we can say, or a -0.625. Okay, so you can leave it as a fraction or you convert it to a decimal. Look at your answer choices if it's a multiple choice question and see which answer, which option is there. Okay, and choose, of course, always choose the very best answer. All right, so we have our slope. The other thing that we want to make sure that we understand is the difference between writing a recursive form of the linear equation and the explicit form of the linear equation. Recursive is when you have to write, or is when you have an equation where you need the previous number to get the next number. Okay, so recursive formulas, and I should say formula, sorry. Recursive formulas and explicit formulas. Recursive formulas is where you need the previous number to get the next number. You need the previous number to get the next number. Okay? And explicit formula is where all you have to do is substitute the term or the number that you're looking for into the equation to get the direct answer. Okay, so with explicit formulas, all you're doing is substituting the term that you're looking for and you'll get a direct answer. You can substitute anytime that you can substitute the term that you're looking for into that formula and get the direct answer, then you know that's an explicit formula. So you can substitute the term you are looking for into the equation or formula, however you want to say that, and get the direct answer. Get the direct answer. And let me make sure you know that this is saying direct. So you don't need the previous number to get the next number. Okay? And there are different kinds, many different kinds of recursive formulas, as well as there being many different kinds of explicit formulas. Okay? All right, so let's talk about the most common recursive formulas. Okay, most common recursive formulas look like this. Recursive. Oops, sorry, y'all. There's one that they use most often, which is called your next now. They use this one a lot. They use next now, and they say next time equations. I better write the whole thing. And this is what that looks like. Next now equations, if it's a linear function, and they are, and it looks like this, an example. Oops, I said equation. And I'm supposed to write example. If it looks like this, your example is y is equal to 2x plus 5. This is an explicit, but to write this as recursive using next now, you always going to write your starting at, okay? You're starting at, so you're starting at the number 5, okay? And then your equation is going to be, oh, sorry, you're going to write it as next equals your now, and your slope is 2. So it's increasing by 2 every single time. So you're going to say plus 2. This is how you convert. This is your explicit formula, okay, to your recursive formula. All right. This is your explicit formula going to your recursive formula, okay? All right. Again, if you have questions about that, please contact me and let me know that you still don't understand the difference between explicit and recursive. Now here, if I'm looking for the fifth number in this right here in this list, or in this particular pattern, then I have to do this 5 times to get my answer. Here, if I'm looking for the fifth, all I have to do is plug in the fifth. Okay, I can plug in 5 to figure out what my answer is. That's the difference between these two. Recursive, you have to keep going, keep doing it until you get your answer. Okay, till you get the term that you're looking for. Explicit, you can just substitute the term that you're looking for and get your answer directly. That's the difference between the two. Now we want to do how to write a linear equation. How to write a linear equation, okay? These are the steps to writing a linear equation, and it's always going to stay consistent, okay? The first thing you do is find the slope or rate of change, okay? You're going to find the slope or rate of change. Now, sometimes, in many cases, the slope is given to you. The slope is given. And sometimes you have to actually use the slope formula to figure that out. Okay, so either way, you're going to find the slope first. If it's a word problem, sometimes they may either give you the 2 points to help you figure out what the slope is, or they are going to just give you that slope. Okay. All right. The second thing that you have to do, okay, because remember, when you write an equation, you write it in y equals mx plus b form. So you need an m, which again is the slope, and you need a b, which is the y-intercept or starting amount. So the second thing, obviously, that you're looking for, if you have m, you need a b now. So you're going to find b. Now, there are different ways, obviously, that you can find b. You're going to use y equals mx plus b and substitute the information that they give you from either the word problem and solve for b. Okay, and solve for b. Okay, and solve for b. All right. So now number 3, lastly, you're going to take your m and your b and plug it into y equals mx plus b. So you're going to take m and b, whatever numbers you found for both m and b, and substitute into the slope intercept form. And remember, I told you the slope intercept form is y equals mx plus b. Okay, so these are your steps to writing a linear equation there. Okay, now lastly, okay, the last thing that you need to make sure you understand how to do is you need to make sure that you know how to graph. How to graph linear equations. Okay, so there are 2 ways to graph, you're either going to use the calculator, use graphing calculator. You have to have a graphing calculator in order to graph equations or linear equations in general, really. And then two, you're going to you're going to use coordinate plane. You could do, well, actually, you could do a table. You can create a function table, and the other is you can actually use the slope intercept form y equals mx plus b to graph linear equations, okay? To graph linear equations. All right, so let's talk about that last one because we already know how to do the other two. We know how to use the calculator and we know how to create a function table. So that last one, graphing linear equations. Okay. When you graph linear equations, if I have y is equal to 1/2 x plus 4, I label my m and my b. That's my first thing. This is my rise. This is my run. My b is, of course, 4. Okay. I'm going to find, I'm going to graph it. I'm going to find b on the y-axis. 1, 2, 3, 4. Okay. This is my starting amount here. This is my y-intercept. This is where my line crosses the y-axis. So I do that second. Now I'm going to take rise over run and put points on the line. That means my rise is up 1. I know my line is going to go up. So I go up 1 and over 2. If I want points in the opposite direction, I go down 1 and over 2. And then this is how I create my line or graph my linear equation. Okay, now I'm going to go over those problems. All right, so now we are going to go over this, the linear functions sample questions. All right, it says Mrs. Morris gave her students this pattern in white tiles. So we got our white tiles here, and this is the pattern. It says she asked the students to write an equation to represent the white tiles T for the figure number N. Okay, so let's count the white tiles here. This is shaded in the middle. We got 1, 2, 3, 4, 5, 6, 7, 8. Here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so this is what we're looking at. Okay, so now it's asking us what is the it's asking us which equation represents the number of white tiles. So I'm going to draw an X and Y chart so I can see it a little bit better. So 1 is X. This is the first pattern, and it's 8. The second is 12. The third is 16. And the fourth is 20. Okay? So we can clearly see that it is going up by 4. 8, 9, 10, 11, 12. That's 4. So we're adding 4. So my M is going to be 4. Okay. So I can eliminate where you see the slope is another number other than 4. So the slope here is 1. So eliminate A. The slope here is also 1. So eliminate B. So now I'm just looking at these. What's my starting amount? Where my starting amount here, I don't see. I see the first number, but I don't see the starting amount. So I got to work backwards to figure out what my zero number is. If I added 4 to go this way, I need to subtract 4 to go the other way. So my starting number, my zero number, is going to be 4, okay? Because I'm working backwards. All right. So my starting number is going to be 4. So my equation then is going to be C. Y equals 4x plus 4. All right. Number 2, it says that the chart shows the amount of total salary, commission plus the salary base, paid to employees of a store that specializes in big screen televisions. All right, so first thing that you do here after you read it, you need to read the graph. The number of televisions sold is X, and the total salary is Y. Okay, the total salary is Y. And I know that when I'm reading slope, it's always going to be the meaning of Y over the meaning of X. So I have my salary per television. Okay, so I have the amount of money per television. All right, the amount of money per television. All right, is going to be my slope because, it's always going to be meaning of Y over the X. So cost, this is money. We got cost per number or per television. Which is the equation that best represents the total salary, T or Y, because we just said that represents the employees that an employee makes selling a number of televisions. So let's first look at when we write a linear equation, we use the slope intercept form, y equals mx plus b. So we need to figure out what m is. And then we got to figure out the starting amount b. So let's find, we know that you see how this rate of change, your rise over your run, do you see how it's consistent here? It's going up by the same amount. So what we're going to do is pick 2 points, or we can count rise over run. It doesn't matter. We can count how far we go up and then how far we go over. So look at this. Up from 150 to 200 is 50. Okay. So our rise, using rise over run, instead of using the equation because that's just easier. It's 50. Our run is we going over just one. It's going up by ones. So our slope is going to be, or our m is going to be 50. Okay. Now our y-intercept is where the line crosses the y-axis. If we continue in this pattern and we work backwards, it's going down 50, right? Okay, so here, this one is going to be, this is 150. So going down 50 is going to be 100. So this is where, if we continue in that pattern, this is where our starting amount is going to be at 100. So my B is going to be 100. So then the equation is y is equal to 50x plus 100. So let's see which one is the better answer here. We got 50 in plus 100. This is our correct answer here. Our correct answer is A. All right, let's look at the next one. Okay, we have school purchases boxes of candy. Each box contains 50 candy bars. That's what each box contains. Each box is $30. How much does the school have to charge for each candy bar to make a profit? Okay, a profit of $10. So let's look in. Of course, let's see. Okay, so if each box is 40 cent here, we're gonna say 40 cent times 50. That's how much is in a box, okay? It's 50. So how much money are you going to make if that's the case? So let's use it says we still can't use the calculator here. So when we multiply this, we're going to get 20. Okay? And you can put that out to the side, 0.40 times 50, 2 zeros and 20. So you got two decimal spaces. So this gives you 20. Okay. So that's $20. So you can multiply it out to the side. All right. And you want to make a profit of $10, but the box cost you 30. So you got to take this that's made and subtract 30 from it. That's going to make it short. You didn't make enough money there. This is going to be $10 short. So A can't be the answer, because if you sell each candy bar that's in that box for 40 cents, that's only going to give you 20. The box cost you $30. You didn't make a profit. You took a loss. So let's try 50 cents. We got 50 cents times 50 candy bars. And this is going to give you $25. Okay? $25. All right. You can multiply that out to the side. All right. 5 times 5 is 25, and got 2 zeros on the end. That's $25. You're going to subtract the $30 that the box actually cost. That's still going to give you a $5 shortage. You don't have enough money. So B is not a good answer. Let's try the 80 cent. So you got 80 cent times the 50 bars. So you got 80 cent times the 50 bars. That's going to give you $40. Okay? This is $40. All right, you have to pay $30 for the box, obviously. So that's going to give you $10 left over. Ding, ding, ding. This is a good answer, because that you made a $10 profit there. Of course, you're going to make a profit with $1.25, because if you know 80 cents give you a profit, this is going to also give you a profit. But we're going to go ahead and make sure we do the math and make sure we have this correct. When we multiply this together, it gives us $62.50. And we're going to subtract $30. So that's going to give us a profit of $32.50, which is more than that $10 profit that we're getting. And they were just looking for a $10 profit. So C is going to be our answer here. Okay, C is going to be our answer. All right, which equation is equivalent to this long equation right here? Okay, so we're going to simplify and see which one of these equations is going to be this right here. So we're going to show each step. Looks like this is written in slope intercept form, y equals mx plus b. So that's the goal here. So let's simplify. Before moving variables to each side, let's simplify each side separately first. So here we can use distributive property, because we have distributive property here, and bring down the y. This is going to be plus the 2x. This is going to be plus 10. 2 times 5 is 10. Bring everything down. Nothing to simplify on this side. Combine like terms here. There are no terms to combine. So now we're going to start moving. Things. Let's move the 2x by subtracting 2x. You can only subtract 2x by terms that are like it. So it's gone from over here, which gives you y plus 10. And on this side, this gives you a 2x. Bring down the plus 5. Okay? So now we're going to move the 10. We're going to subtract 10 on both sides. So when we subtract 10 on both sides, this gives me y. This is gone. This gives me 2x. And this right here gives me a minus or a negative 5. So our answer here is going to be C. Number 4 is going to be C. Okay. All right. Let's look at number 5. It says Jesse's bus ride to school is 5 minutes. Okay. So let me write this out to the side. J is 5 minutes more than 2/3 of Robert. So 2/3 times whatever Robert is. This is Jesse, okay? And all I did was just write it out how it was read. 5 minutes more than, so we got 5 plus more than 2/3 the time of Robert's of his multiplication. So we're going to multiply 2/3 times whatever R is. All right, which graph shows the possible time that Jesse and Robert's bus ride. Okay, so basically they're asking me to graph this equation that I just wrote. Okay, where Jesse, of course, is y, and you can see along the side. Look at this. Jesse is y, and Robert is x or R, I put R here, but it's X. So I'm going to look for the y-intercept first. In this problem, my y-intercept or my B is 5. Okay, so my line crosses at 5. My line does not cross at positive 5 here. A is not my answer. It crosses at positive 5 here. So this is a possible answer. It crosses at positive 5 here. So this is a possible answer. And it doesn't cross at positive 5 here. So D is not a possible answer. Now I'm going to find my slope. My rise over my run is 2 over 3. This is my rise. This is my run. So let me start here. So basically you can't see whether it rose 2 and went over 3 because they're using different increments. So you just need to figure out, pick 2 points on the line and see if the slope is going to be equivalent or equal to 2 over 3. Okay? All right, so let's do that. I'm going to pick 2 points. I know this point right here is 0, 5. This is X, this is Y. And I know, let's choose another point that I know for sure. And I know this point right here, choose a point you know for sure, is 30 and 25. So we had 30 and 25. X2, Y2. So this is going to give me Y2. Remember, this is what I'm using. Okay. So on the top, this is 25 minus 5. And on the bottom, this is 30 minus 0. Okay, so this is going to be 20 over 30. When I reduce this by dividing by 10, it's 2 over 3. Ooh, that's my answer right here. B is the best answer. Okay, if I do the same thing for this one. If I choose 2 points here, I get this one, and I get, let's see, looks like this. So my 2 points is 0 and 5. And my other point is 10 and, what is this, 20? All right, so using the same slope formula, on the top is 20 minus 5, and on the bottom is 10 minus 0. So this gives me 15 over 10. So 15 over 10 doesn't reduce to, let's reduce it. This is 5 divided by, okay, so this is give 3 on the top and 5, this give me 2. So this is 3 over 2. And 3 over 2 is not the same as 2 over 3. So my answer is B. Okay, my answer is B. All right, if you still have questions about that, just let me know, okay? Dennis compared the y-intercept of the graph. This is the graph right here. This is my f of x. And the y-intercept of f of x, got f of x is equal to 3x plus 5. My b, or my y-intercept here, is 5. Okay? So he's comparing this y-intercept, which is 5, to the y-intercept of the graph. So this is calculator active. So yay, I can use my calculator to figure out what the y-intercept is. Clear your calculator, second plus 7, 1, 2. And go to stat, edit, and we're going to type this in. We have negative 7, negative 5, negative 3, negative 1. Okay, then we have 2, 3, 4, and 5. Okay, and we have second, go down to linear reg. All right, and this is what this gives you. So your y-intercept, you see in the calculator, is 5.5. So let me write my equation for this g of x graph. It's going to be, look, 5x plus 5.5. Do you see how that the a in the calculator is m? All right, so now my b here is 5.5. So it says here, and we're comparing them. That's what it said initially. It says, what is the difference when the y-intercept, of f of x, this one right here, is subtracted from the y-intercept? So you're going to subtract this from this. So you got 5.5 and you're subtracting 5 from it. and that gives you 0.5, a positive 0.5. So positive 0.5 is C. Okay. All right, so let's look at number 7. Number 7 says the boiling point of water, okay, T measured in degrees. So T, that's the boiling point of the water. It says at A altitude, which is measured in feet. So the unit used for T, and notice how it's a capital T, so it's probably going to be Y, okay? And the altitude is measured in feet. Okay, so this is probably X because it's lowercase, okay? And what do you know it is? Because look at this. You see how T is of A, so that's Y, like F of X. So this is really Y, okay? Is equal to this equation right here. In terms of altitude and temperature, so we got altitude and temperature. Altitude is X, temperature is Y. Which statement represents the best meaning for slope? So first of all, let's identify what the slope is in this problem. The slope in this problem is equal to negative. So it's a negative. That means the line is going down. Okay. So we're only identifying, this is what we're looking for. This is the slope. And remember, this is degrees per altitude. Or degrees per feet. All right, because it's y, always y over x when you're talking about the meaning of slope. So let's look at it. It says A, and I didn't mean to circle that. The boiling point increases, so that means y is increasing. And remember, look, this is a negative. So y increasing by 18 degrees at an altitude that increases. Well, X is always going to increase, okay? But Y, because it's a negative, decreases. So this is not my answer because it says increase and your slope is a negative, okay? So any place where it says Y is increasing and you have a negative slope, that's not your answer. So the boiling point increases. Again, that's why. Y is not increasing here. So this is not your answer. Okay, so the boiling point decreases, that's good, by 18 degrees at an altitude that increases. X is always going to increase by 1,000 feet. So this could be a possible answer right here. Okay, the boiling point decreases, good, by, look at this, 1.8 degrees as the altitude increases. This could be a possible answer. Let's see which one is going to equal this number right here, though. So you have 18 on the top. That's your Y, because Y is on top. Remember, Y is on top. Y2 minus Y1. Y is on top when we're talking about slope. Divided by the altitude, 1,000. X is on the bottom. So let's divide and see what that gives us. We got, 18 divided by 1,000. And that gives us here 0.018. Okay. Now the last one is 1.8 divided by 1,000. Okay. So we got 1.8 divided by 1,000. And that gives us 0.0018. So our correct answer, and don't forget that it is negative, our correct answer is going to be D. D is our correct answer here. All right, let's look at number 8. Mario compared the slope of the function graph below to the slope of the linear function that has the x-intercept. So you got your x-intercept of 3/4 and your y-intercept of -2. So your x-intercept crosses the x-axis. If it crosses the x-axis, that means your y is 0. So this is what that ordered pair looks like. This is x, this is y. Your y-intercept crosses the y-axis, so this is what this ordered pair look like. 0, -2. Okay? This is x, this is y. All right, what is the slope of the smaller function? So let's find the slope here, okay? The slope compared of the function to the graph. So we're comparing the slope that they give us here to the slope that they give us in the picture. We're comparing these slopes. So we need to figure out what this slope is here. So we're going to use the slope intercept form for this. The slope formula, y2 minus y1 for the points that they give us, and use rise over run for the line. All right. So let's do this first. Let's use these two. X1, Y1, X2, Y2. So on the top, this is -2 minus, okay, let's see here, minus 0. And this is 0 minus 4. Okay, all right. So this on the top is going to give us a -2. And on the bottom, this is going to give us a -4/3. Okay, so let's divide and see what we get as our slope for this one. All right. Okay, so we got -2. Look at that. Type that in. Divided by, and let's type in this fraction. We got the fraction -4 divided by 3, and then close the parentheses. All right. And let's go ahead and write this as a fraction. So this is math and enter. So this gives us 3/2. So 3/2 is the slope for this. Okay. So now let's do rise over run for this. So pick 2 good points on the line. Oh, let's see. 2 good points on the line, Lord. Let's start down here. Looks like this point is a good one. Looks like this is a good point too. I don't know. All right. So I probably overlooked some points, but you got to be 100% sure. All right. So it's going up by 1. So let's go up 1, 2, and 3. So the top number is 3. And let's go over 1, 2, 3, 4, 5, 6, 7, 8, 9. I did skip some. All right, so 3/9, and that gives us, let's reduce, divide by 3. This gives us 1/3. Okay? All right, so what is the slope of the function that is smaller? So out of these two, this is your smaller number. So the slope of the smaller one is 1/3. Okay? 1/3. All right, so B is your answer. All right, the table below shows the distance of the car the distance that the car has traveled. So again, what is the meaning of the slope of this linear model? So all you're doing is pick 2 good points. Let's do, this is X and this is Y. X is always time. So this is 25, 20, X, Y, first point. And let's do 50, 40, X2, Y2. Using the slope formula, Y2 minus Y1 over X2 minus X1. All right, so this is what this gives me. I get, Y2, which is 40, minus 20. Then X2, which is 50, minus 25. So on the top, this gives me 20, but on the bottom, this gives me 25. When I reduce this, I can reduce this by dividing both the top and the bottom by 5. This gives me 4/5. Okay. Remember, the meaning of Y is on top and X is on the bottom. Your Y meaning is your distance traveled. Okay. So that's 4 miles. Your X is minutes. So 4 miles per 5 minutes for every 5 minutes. Okay. So look at what this says. It says A, the car travels 5 miles. No, it's 4 miles. The car travels 4 miles every minute. No, not every minute. Okay. The car travels 4 miles every 5 minutes. Yes. That's going to be your answer there. Okay. I'm going to read the last one just to make sure. Oh, that was the last one. Oh, well. So that is the answer. All right. Cell phone. Cell phone company Y charges $10 startup fee. Okay. So for company Y, your B is equal to $10 plus 10 cents per minute. So your M is going to be 10 cents. So the equation is y is equal to 10 cent x plus 10. So now for your next company, your company Z charges 20 cents per mile. Oops, sorry, y'all. 20 cents. Decimal was in the wrong place. So that's your M with no startup fee. So it's 0. Your B is equal to 0. No startup fee. So that's Y is equal to 20 cent X. Okay? Which function represents the difference in the cost? So you're subtracting these two costs from each other to see which one of these represent the equation. So you're going to subtract 0.10 x plus 10 minus that 20 cent x. You can only combine the terms that are like. So you're going to subtract these two from each other. Okay. So difference in cost between Y, we got Y first, the Y company first, minus the Z company. Just making sure we have it in the right order. All right. And so when you subtract, that gives you a negative 10 cent X. Make sure I put the decimal right, because you see how this is and this plus 10. So my answer here is going to be B. This is the correct answer here. Negative 10 cent X plus the 10. Okay? All right, let's move to the next one. Okay. All right, what is the value of W? Okay, so we're going to do what is the value of W? So all you're doing is solving this equation here. So we got 3 over 4 W plus 8 is equal to 1/3 W minus 7. So move the variables to the same side because we don't have distributive property. So I'm going to move the smaller one because it's easier to subtract the 1/3 W. The 1/3 W from this 3/3 W is 2. Oh, wait a minute. You know what? They don't have the same denominator, right? So I'm going to use my calc. So the parentheses 3 divided by 4, which is 0.75, minus parentheses 1 divided by 3. And I'm going to keep it as a fraction. So math, enter, and that's 5/12. Okay? So we got 5 over 12 W. Okay? So that's what we have so far. Then we got plus the 8 is equal to, and then what's left here is minus 7. All right. So now we move the 8 by subtracting the 8. Okay. And don't forget, if you don't remember your rules for integers, you can type those in the calculator, just like I did right here. You see that? Okay. And this is here is 5 over 12 W. This is negative 15. Now I'm going to get rid of the 5 over 12 by multiplying by the reciprocal on both sides. So this is 12 over 5. This is 12 over 5. So this gives you W is equal to, okay, and we got the negative 15 times, let's do parentheses, 12 over 5, right? And this is equal to 36. Negative 36. So W is negative 36. And I knew it was going to be a decimal, so that's why I didn't change it to a fraction there at the end, because my answer choices were decimals. Okay, so number 12 is what is the slope that contains these 2 points? So here you're going to use the slope formula, y2 minus y1 over x2 minus x1. I'm so sorry, y'all. This is a long video. I just wanted to make sure that I got everything in that I needed to get for you. We got x1, y1, x2, y2. You can always pause it and come back. All right, but we are almost finished, literally almost finished. All right, so here my y2 is 14 minus my y1 is 12. 2, y'all. Then we have x2 is 3 minus the x1 is -9. So this gives me 12 on the top, and this gives me 9, 10, 11, 12 on the bottom. So 12 divided by 12 is 1. So my answer here is 1. Okay. All right. Approximately. Okay. This is a different kind of problem. If you probably might not remember this, but this is line of best fit problem. It says, what is the percent of boys ages? What percent of boys ages? And keep in mind, there are 7 boys. Let's count them. 1, 2, 3, 4, 5, 6, 7. There's 7 boys. And so they said, this is the shoe size of the boys, of each of these boys. And this is the ages of the boys that took this little survey. So make sure you understand that part. They want to know what percent of the boys out of these 7 boys, got a total of 7 boys, is more than 1 year difference from the predicted line of best fit for the data. So this is the actual. So we got to do we got to find the line of best fit by doing linear regress in the calculator. So let's do that. Let's clear 2nd plus 7, 1, 2. Don't forget, this is how you do the line of best fit if you've forgotten. Your line of best fit for a linear equation, go to Stat, Edit, type in your X and your Y, and do linear regress. So we got 6. Okay. And then here, 9. Let's make sure I'm matching it up rightly. I just made up a new word. Lord, please help me. Help your teacher. Oops. Okay. Yep. So that's right. So now you go to Stat. You go to Calc, Lean Reg, and then you get an equation. And this is your equation here. Okay. So I'm gonna just round it off. We got a line of best fit. Let's do 2 decimal spaces. Y is equal to, and we got 1.13. Since you know that we're rounding, we got to choose the closest answer because you know it's not exact now. 1.13. I'm tripping on that. I'm sorry, y'all. And look at this one. This is 4.1. Okay. So now what we're going to do, we have our line of best fit, is now it says what percent of boys' ages is 1 less year different. So when we plug in our X value, we want to see how if the Y value, which is the age that we get, is which one is more than a year off from the Y value. Okay, so let's plug in 6 and we should get somewhere around 9. It can't be more than a year off 9 though, because if it is, then we're going to put a check beside it so we can see how many or what's the percent that are more than a year than this actual or predicted age. Sorry. So we got Y is equal to, let's plug this in. Let's plug in 6 here. So we're going to plug in 6 here. I probably should just put them in the calculator to see, huh? I could just type them in here. Go to Y equals. And I could have done Stat, Edit, Lean Reg, right? And then here, second 1, comma, second 2, since I can use a calculator, put the comma, vars, you might want to practice this a couple times, Y vars, and then press enter 3 times. What this does is puts this equation in the y equals. So now I can use my function table to do this problem. So it automatically puts the equation here. So now let me go to table setup. This is a little trick right here. And this time you see where it says independent, that's my X. I want to type in my own X values. So go from auto to X and press enter. Now let's go to the table, second table. So now I can